Good morning, good afternoon, good evening, everyone. I'm Rob Meyer with Grid Gain. We're going to begin in just a second, but first I wanted to make sure we go through a little bit of housekeeping so you understand how to use the chat feature so you can ask your hard questions. If you could just raise your hand quickly, if you know how to do that, there's a little hand symbol in your right-hand side window of the GoToMeeting. That way I'll know that you can hear me. I do see some mutes. There we go. We have a hand. Great, couple hands. And here we go. We see some more. All right, so you're going to be on mute just in case you try to talk. During the discussion, if you want to ask questions, there's a questions tab on the right-hand side. You can feel free to ask some questions now and experiment. I'll be answering some questions throughout the webinar, but I will save the hardest ones for our speaker today, who is Dennis Magda. Dennis is the Ignite PMC chair. He also runs inbound product management here at Grid Gain, and he is going to be our main speaker. He's going to be talking today about not the #2 language on the planet for developing, which is SQL, but the #1, which is JavaScript. He's going to be talking about using Node.js with Apache Ignite. So for those of you who aren't familiar with Grid Gain, we provide the commercially supported version of Apache Ignite. We also happen to provide support for Apache Ignite. And we continue to be one of the biggest contributors to the project. So with that, let me turn it over to Dennis so we can dive into Node.js. Dennis, it's all yours.
Yeah, thanks, Rob, for the introduction. And hello, everyone. Thanks for joining our webinar today. Hopefully, you'll get interesting facts about Apache Ignite and specifically how Apache Ignite can be used together for your Node.js-driven conversation. Applications. So the agenda is pretty straightforward. First of all, I would like to contemplate on why Apache Ignite and Node.js should be used together. Is there any similarity? Is there something in common between a language like Node.js and a memory computing platform such as Apache Ignite? After that, we will switch to the Apache Ignite overview, which is relevant for Node.js applications. I'll for sure some of you might have already heard or used Apache Ignite, and that's why I decided to skip the generic overview and coverage of all the Apache Ignite features. I'll do kind of a high-level introduction of Apache Ignite so that to ensure that everyone with any skill level will be able to understand the rest of the material. But then if you'd like to know more about Apache Ignite technology in particular, in the end of the presentation, I'll share some of the references to useful documentation and other artifacts. After that, after we just discover the high-level capabilities of Node.js support for Apache Ignite, we'll get down to the implementation details. Because personally, as far as I know, usually we deal with two kind of audiences in Apache Ignite. The guys who just want to get and start with the technology as fast as possible, but also there are those who want to know their details. They want to know the insights. And the goal of that section would be just to put out some of the implementation details so that you know how that client is different from other clients developed for other languages Ignite supports. And also I'll just reveal some our ideas for the Node.js evolution, how we are planning to develop and expand this client in the future. And for sure, we'll have enough time to answer your questions. So don't hesitate asking your question using the chat window. So let's move forward and let's talk about the why. Why would the one use Node.js with Ignite? So generally speaking, Node.js is a wonderful programming language. As Rob mentioned, that's kind of second or first runner-up, correct me if I'm wrong, language by the popularity in the world, because it's based on the JavaScript.
It's the number one.
The number one, yeah, the number one. And that's why it would be a mistake for us, not to support this language in general. But what's interesting about Node.js in particular, I just want to summarize some of the well-known facts. First of all, Node.js is best suited for real-time applications. Whenever you need to achieve the fastest response times, whenever you want to process different events in the timely manner without any delays, etc. Node.js sounds like the perfect fit. At the same time, Node.js became so popular for the real-time applications because of the way how it's designed. For some of their developers or architects, those design decisions might look like bottlenecks or flaws, but their time confirmed that even though Node.js is a single-threaded framework, a single-threaded language which is based on JavaScript still, that capability, that architectural specificity allowed Node.js to use all of the available resources wisely in a prudent way. And for sure, it has some limitations. For instance, it's discouraged to use any compute-intensive tasks. But yeah, which means that you might not be able and should not even try to run any long-running computations with Node.js, but instead you can execute your queries in the fastest ways possible and with the minimal resources utilization. That I think was one of the cornerstone ideas of Node.js. So Node.js, you shouldn't see it as a tool, as a language for all of the possible use cases, but at least if we are talking about the real-time applications and solutions, that can be one of their best fits. And how does it apply for Apache Ignite? Node.js applications, as any other applications written in other programming languages, has to interact with the data layer, with the storage, with some computational system. And Apache Ignite is your in-memory computing platform, which can be used as a memory cache, or as a memory data grid, or as a memory database. And the problem, and as well as Node.js, Apache Ignite solves some particular problems. It's not a silver bullet, right? But we know that it's designed for some specific use cases. The primary goal is which Ignite is solving is performance and scalability issues. Like whenever you want to scale horizontally, or you wanted to get rid of your single machine deployment bottlenecks, Apache Ignite can be considered as a good option. And the reason why it works this way, because Ignite comes with ultra-fast distributed memory-centric storage. And as I already mentioned, it can be used in different flavors. The simplest flavor as a cache, a memory cache, or more sophisticated deployment scenarios, such as a memory data grid or a memory database. So let's quickly jump to the next slide. And those of you who are not familiar with Apache Ignite, I just want to spend 3 or 5 minutes of your time briefly covering how Apache Ignite looks like. So when we talk about Apache Ignite memory-centric storage, we are considering two things. First of all, Ignite comes with its own in-memory data store. And initially, when Ignite was developed and the first version was released, his biggest capability and advantage was that storage, so that all of the APIs which sit on top of that storage are well integrated with it. So it's not enough, just to put data in memory, but also it's crucial to implement and couple your APIs with your in-memory data structures, with your in-memory storage. And that's why Ignite became so successful as a memory computing technology. It came with its in-memory storage, and on top we supported key value, SQL, compute grid, which in fact is the same as Hadoop MapReduce calculations, transactions, service grid streaming, etc., a variety of different APIs. At the same time, whenever we are talking about in-memory computing technologies, companies still want to have a persistence layer, because your distributed cluster can go down, and for sure you don't want to lose your data. And whenever we are talking over persistence layer, again, Ignite comes with a rich set of possibilities. For instance, whenever Ignite is used as a memory data grid use case, then most likely you're persisting your data to a relational database or to a NoSQL database. And that synchronization and persistence happens automatically for you, for your applications. So here is if to compare, let's say, Ignite as a memory data grid to, let's say, memcached as a memory cache. If you are working with memcached and you still have your persistence, which is MySQL database, then your application's responsibility is to keep both memcached cluster in your MySQL database in sync. But when it comes to in-memory data grid use cases, everything is transparent for your application. Your Node.js application will be working with your distributed in-memory cluster, which is Ignite, using Ignite's APIs. And Ignite automatically will push all of the changes in a consistent way to your MySQL database. Just one of the examples. Or as another alternate persistence option is Ignite native persistence, which easily integrated in the memory-centric architecture of the product or the project. And it allows you to distribute the data across the cluster evenly across both RAM and disk. And all of the APIs which are supported for in-memory data store for sure will be supported for their native persistence layers. There are several reasons like why would you use a third-party database like MySQL or Ignite native persistence, but I would skip this conversation for now. And if you're curious on this, you can go to our documentation or website and find out more about this. Or we can discuss this during our Q&A section. And before we move to the Node.js conversation, how Node.js applications work with Apache Ignite, here is on this slide, I just want to bring up one of the most widely used Apache Ignite use cases, which is a memory data grid, which we already covered. So here is the idea, simple. On the first slides, right, I mentioned that Ignite solves performance and scalability problems. So what might happen with your Node.js applications which are going to a relational database? The relational database can become a bottleneck at some point of time, which will influence the real-time aspects of your Node.js applications. Your Node.js stack will not be able to respond or in time, or it will not be able, to work faster because the database became the bottleneck. And Ignite here is used as a possible solution. Ignite can be deployed as a layer, as a memory layer between your Node.js stack in your relational database. The whole data set will be stored in RAM, and you will be able to use a variety of APIs from your Node.js applications. Your migration should be seamless. You can use SQL, or you can use key value, you can use transactions, whatever you need. And the same story is, so the reason why we are showing this slide, because the same story happened with our Java, .NET, or C++ community. And we do believe that the same problems exist in Node.js for Node.js application and services. That's why we want to give you some insights why Ignite can be useful for your Node.js applications. And now let's talk about the technology, right? Now let's switch to the technical questions. So for instance, speaking of Apache Ignite, Apache Ignite is a distributed system. It's a distributed storage. So basically you would use it as you use Redis, MongoDB, or Cassandra. You would deploy a cluster of machines, and those machines will be keeping your data in memory and on disk in the way you like. And here is, if to define what are the types of the nodes available. In Ignite, we have two kinds of nodes. The first one is server nodes. Server nodes are your containers for your data and computations. So basically, if you take a look to the right of this slide, here is we have a group of interconnected server nodes, which are called the Ignite cluster. And once you have all of those server nodes interconnected, you will have your distributed storage, your distributed database. And for your applications, which are connecting to this cluster through different client connectors will be working with this database, will be seeing this database as something, united, as a single deployment, as you would work with MySQL. That's like, the transparency. All of the complexity implementation details are hidden for your Node.js applications. And clients, right, there are many clients, but when we talk about Node.js stack, then here we have specially client developed for Node.js ecosystem. And what you would use, let's say you have your Node.js application, which needs to connect to a backend storage. And for instance, now we're using a SQL to retrieve data from that storage. And if your storage is becoming the bottleneck, you're deploying Ignite and you're switching your applications to that Ignite cluster. You can keep using SQL, or you can even switch to more sophisticated or even fast APIs like key value calls. And from the implementation standpoint, Node.js client is pretty lightweight. So it will not disrupt, it will not affect the principles of Node.js applications, which are designed for real-time processing. So if you connect it to Ignite clients from your Node.js applications, you also can expect that that client will be working in a real-time manner. So how the connectivity happens? So presently in the current version of the implementation, you're connecting the client connects through an IP address to one of the server nodes. And that server node will become your proxy. So all of the queries, all of the calls coming from your Node.js applications will go to that server node first, and then that server node decide where to redirect your request, which node stores the data, a data entry, which is requested by your Node.js application. That happens. But going forward in a couple of in 10 or so minutes, I'll explain you how the client is implemented in details and what to expect next. Speaking, if to talk about the APIs, presently we supported the most crucial APIs which are required for real-time nature of Node.js stack. For instance, key value calls, key value APIs. I would say the most fastest way to retrieve any data set for any distributed system, let it be Redis or Cassandra or MongoDB. Whenever you have a primary key and you need to get a data set for that primary key, that's the fastest way possible to get a response from your distributed system. SQL for sure is also available. That's much more, it goes with much more advantages. It can help us run more complicated queries, range data, do grouping, order your data, etc., etc. And Ignite comes with NC99 SQL. So it's extremely sophisticated. It supports selects, inserts, updates, whatever you need. I bet that you might not even see any differences from the syntax standpoint or from the capability standpoint once you switch to Ignite. And if your Node.js applications previously used SQL heavily, also scan queries are handy if you want to scan through a data set stored in one of the tables or in one of the caches of Ignite. And also for sure, you can configure your caches or tables from your Node.js applications. You don't need, to predefine the whole data model, data structure statically before the deployment happens. You can keep doing this in runtime when your application is already in production. So now let's take a pause and quickly check how to run the first Node.js application. I just want to show you that it's pretty straightforward and simple. So what I did as part of the preparation for this webinar, I went ahead and downloaded Apache Ignite from the website. Give me a second. Yeah, being here. So now I'm located in downloads folder, Apache Ignite 2.7. I took it from the website. And what I want to do now, I want to start Apache Ignite server node. And I will be using my local laptop. So basically, what's good for the developer, for Node.js developers, you don't need to provision Apache Ignite cluster in your company's infrastructure or in the cloud, just if you want to start with the functional development. yeah, it's meaningful to do this when your functional scope of your project is done, and now you want to test performance. But while you're coding, while you're creating the functionality applications, it makes total sense to start your local clusters on your local laptop so that you can keep developing as quick as possible. And here is what we can do. I'm using macOS application, and for Unix applications, we release Ignite SH script. So if you use this script, you will be able to start your server node on your local laptop. So I'm starting the first node. You can start your node from your IDE. I usually prefer to do this with a console environment. So you can see here that we've got the first node running on my laptop. There is just one server node, no any clients connected, etc. And now I want to repeat the same procedure. I'm starting one more node. So effectively, I'll have two nodes cluster. All right, I have two nodes running, two servers running on my local machine. And also now what I did, if you go to the same folder, let me show it to you. You even don't need to create your first application for .NET. You can play with some of the samples which are available as part of Apache Ignite release. So if you go to downloads Apache Ignite platforms Node.js examples. Here you will see a list of different examples which were created by the community. And what I did, I'm using WebStorm IDE, and I opened these examples as a project in this IDE. And let me just quickly show you the most easiest example we can run for Node.js. So here is what we have. Some of the constants and variables definition, like Ignite client objects. I wouldn't, waste our time reviewing this part. But what I'm interested in is that how we start. So basically, we are going to open Ignite. We are going to create an instance of Ignite client, and that Ignite client will connect to this address, to one of my server nodes, which are already running. Right, we did this before. After we connected to this endpoint, we are going to create caches. So a cache, think of a cache as a table of the relational database. So it's the same. We are creating the cache, and then we are putting some data into that cache. So basically, I'm putting objects like person, name, last name, salary, etc. That's what I add into my cluster. I did a minor change with this example. I commented out this operation. So I don't want this cache to be destroyed after the application completes the execution. I want this data to sit for a while in the cluster. So now let's start this application. Pretty straightforward and easy application. So now it's done, it's executed. So we could connect to the cluster. We created caches, and we put some data, and then we read some data back. So what happened here? So no any exceptions, the cluster operates normally. But to be sure, like now I am as a developer want to confirm that the data is still in the cluster. What can I do? I can go to Ignite Web Console. So for instance, usually whenever I want to play with and manage or monitor my cluster, I'm using console gridgain.com, Ignite console, which is deployed by gridgain on their premises. So I just log in there, and now I will be using the monitoring tab and management tab of that tool to connect to my local cluster. So now what we can see is that there are no any metrics yet because I've just opened the screen, but technically here is my two nodes, right, which are running on my local laptop. I can see CPU utilization, GC utilization, like and other parameters, memory settings, and here is we have caches. That's the cache which was created by my first application. That's how many entries we have. It's tiny, right? But anyway, so the goal was to show that we will be able to manage and monitor the cluster. What you can do next, for instance, you can stop or destroy these caches if you no longer need them. So all of that is possible to do from here. Next, so that was the first application, right? So I hope that you could see that it's pretty easy to start your Ignite cluster on your local laptop. You just even don't need to be an expert in Java, right? As a Node.js developer, you just can use our Ignite SH script to start your first cluster nodes, and after that, you can switch to the familiar environment for you. You can write your Node.js code using your favorite tool like WebStorm or anything else, and then from that applications you can connect to your distributed cluster. Yes, now this cluster is local on your laptop, but once your application, your code is ready, go ahead and deploy your cluster in your cloud environment or in your other environment, and you will be able to use it at much larger scale. All right, let's switch back to the slides. So what else do we have for you? Speaking if to talk about SQL capabilities, the reason why I want to pay a little bit more time to that is because historically, when Ignite was helping to solve speed and scale problems for Java and .NET communities, a lot of the applications initially were designed with the usage of SQL language. And the migration to Apache Ignite was always pretty, not even simple, I wouldn't say simple, but at least it was much more simple than it would be to any other distributed systems and technologies because of SQL support. So if you're already using SQL, you can keep using SQL after applying some of their recommendations such as data affinity collocations, tuning optimizations, etc. But the whole point, what's available for you, you can keep using DDL or DML statements. So even you can use our cache APIs to create your caches, or you can use create table commands to create the tables instead. And those tables will be used the same way as you would use caches. You can use select, update, and insert to access your data. And all of those APIs are sitting on top of our memory-centric storage, which consists of two components: in memory storage and your persistent storage. And when it comes to persistent storage, again, if to repeat, you have two options: a third-party database such as MySQL, Oracle, or Postgres, etc., or it can be Ignite native persistence, which is much more scalable and comes with other exciting features. So, and if I would show you an example, let me also quickly show you an example of SQL application for Node.js. So I'm switching back to my IDE, and here is in the examples folder. For instance, let's take this SQL example. So again, another Node.js application, we are connecting to the cluster. Again, here is we want to create. That's like a workaround which we are using from the API standpoint right now, and will be this usability issue will be addressed in the next releases, but basically because it's unrequired. But next, once you connect to the cluster, we are creating our database objects. So we are creating our tables like country tables with some of the fields, city tables and country language. Here is we are applying affinity collocation concept. So affinity collocation concept ensures that all of the cities whose country code is the same will be stored on the same cluster machine. And this data distribution allows you to apply tremendous optimizations and get tremendous performance benefits in the with the distributed systems like Apache Ignite. So as a homework, if you are not aware of affinity collocation, just check this concept out in the end of this webinar. Or if you have more questions, you can address them later to us. So once we created these tables, we can create indexes with SQL language as well. And after that, we can put some data. We are inserting this data into the cluster, countries, and then we would like to select some data. for instance, the most populated cities in the world, or the most populated cities in the countries such as United States, Russia, and China. Queries like this. Pretty simple. So again, here is what I did. I decided that I don't want to destroy those tables and caches after the application ends. So let me start this application again. We could connect to the cluster. As I see, we could create those tables. Here is the list of the most populated cities based on that data set. And that data set, I don't know like how, whether it's actual or not, but that's like what it shows. The most populated cities and some other information. If we go back, if we jump back to our web console, here as we can see some of the changes with our metrics. We could see that their heap utilization went up, so some changes happened there. CPU was slightly used. That's what you can see. Cache size, data size grew to 40 entries, almost 40 entries, right? And the same number of cluster nodes. And here is I have my caches tables like created, and total number of entries, primary and backup copies. Also, what you can do from this tool is to run your SQL queries, right? You can code them in Node.js, add them to the Node.js applications. But before even you create a function for Node.js, you can try them out from this management and monitoring tool. For instance, I have the same queries predefined here, and I can experiment with them running from web console, like the same result set. So web console connected to my cluster, and it can execute the same queries. All right, that's it. That's how you can start, and that's how you can start creating your first Node.js applications for your Apache Ignite clusters. All right. Now going back to the details, right? I promised to share some of the implementation details for those who are curious about how the things work under the hood. So first of all, Node.js client is based on our is one of our thin clients, so-called thin clients. All of the thin clients or lightweight clients, they are based on our socket level binary protocol. Socket level, like just TCP/IP sockets, and that protocol is cross-platform. It doesn't matter what's your favorite language. It can be Java, .NET, C++, Python, or Node.js, right? You can always create an implementation on top of this binary protocol. And that's exactly what the community did for Node.js. We took this protocol, which is embedded into Apache Ignite, and we provided a library, a native library for Node.js application. And today, as I showed you, I was using that library. I don't see any internal details, any complicated, socket level communication procedures. I'm just creating some ordinary Node.js objects, and I'm connected to a distributed database. And here is, speaking of the supported languages, right? For sure, we have Java, .NET, and C++ for as lightweight clients, and also those clients can be as a little bit more heavyweight implementations. But Node.js, Python, and PHP comes in the implementation or the thin clients flavor. So, and here is, those of you who have been using Ignite for a while as a Java developer, .NET, or C++ developer, you know that there is another type of clients available, so-called regular client or thick client. And now, as long as we are talking about the thin clients, what's the major difference, right? So first of all, as we already know about the thin clients, that's a lightweight socket-based protocol when you're connecting through a TCP/IP connection to one of your cluster nodes. And that cluster node, that server node, will become your proxy. So all of the communication goes through that proxy, at least presently, the current version of Node.js or any other thin client. When we're talking about the regular clients, those clients start in a JVM process internally. So if you're using not .NET or let's say C++ regular client, then those clients will start a JVM process internally, and through the JVM process, they will become a part of the cluster topology as regular client nodes, and they will be able to connect to any cluster node depending on the request type. For instance, your application is issuing a request for city with ID 100, and your local .NET application will be able to find out who is the primary owner of that record, and that node will connect to a specific server node which stores this data. So that's much better for the scalability performance benefits, because there is no any notion of a proxy server or proxy node. For the thin clients presently, as long as they're working through a proxy connection, the performance will be lower, it will be worse. But what we are working on is on the direct communications. So generally speaking, we are going to release a partition awareness. So your client still will be connected to one of their proxy nodes, but it will be getting information about the data distribution. So your Node.js applications locally will be aware of partitions. They will know where each record resides. And then whenever your Node.js application wants to get, let's say, a record for city with primary key as 100, it will be able to connect to the key to the entry owner. And that request will not go through the proxy node. That's actually what's supported for the regular clients right now by other means, and that's what we are working on and planning to release for the thin clients, including Node.js. So soon I believe that the scalability and performance, speaking for the scalability and performance criteria, both regular and thin clients will be on par. But if to talk about the supported APIs, regular clients like which are available for Java, .NET, and C++, they support all of the Ignite and Grid Gain APIs available, including compute grid, including machine learning, including continuous queries, etc. Thin clients presently support limited set of APIs like key value, get, put call, SQL, scans, and ability to configure your cluster. We'll see how to evolve those clients, but presently that's the major difference. And if to talk about, if just, to speculate and to talk about our vision, how Node.js client should evolve, first of all, if to quickly jump to the last bullet point of this slide, we are always listening to user feedback. So start using Node.js, switch your Node.js applications to Apache Ignite. If there is any issue, Apache Ignite can solve for your deployments. And share your feedback, because we want to learn from practitioners. We want to learn from developers and architects who are working with Node.js stack. What's meaningful, what's redundant, and what's missing. And after that, we will be able to prioritize. Based on our experience, based on our vision, and based on our experience with previous technologies, with other languages like Java, .NET, first of all, right, we want to increase the performance and scalability benefits of Node.js, like what I've already explained as direct connectivity to service or partition awareness. That's already in our development pipeline, and it will be available, I think, in several months for the Node.js community. So your Node.js, if you start with Node.js right now, your applications will definitely benefit from the speed and scale features of Apache Ignite. But going forward, you can expect even more. And also, based on the feedback, we are thinking that Ignite, one of the Ignite benefits is that collocated computation framework. So when you have some computations deployed, which process data in a more sophisticated way, and you want to trigger those computations on the server side, avoiding data movement from your server side to your applications. So at least what we are thinking is that as long as your server nodes and the cluster is still a Java middleware, right? Someone can create Java tasks which will be deployed on the server side. And then from Node.js applications, you can execute and trigger execution of those tasks. Think of compute tasks as a much more powerful version of stored procedures, much more powerful. And presently you can code those computation with the usage of Java, .NET, or C++. Probably something will be supported for Node.js, but first of all, as I said, we are waiting for the feedback from the practitioners. All right, that's it. Actually, that was a pretty fast presentation, and I hope that you could grasp the high-level idea why Ignite and Node.js can be and should be used together, how you can write your first Node.js applications, which will be working with accessing data sitting in Ignite. And to navigate you further, here is a slide which enlists some of the useful references. For instance, Node.js Thin Client details, more details, how it's implemented, APIs, etc., getting started guide, go to our documentation. Also, we have a series of 2 articles. The first one shows how to start with Node.js. Basically, I showed this today, but in that article, you will learn how to do this from the get-go, like installing from npm.js repository, then creating the application, starting, etc. Also, there RDBMS acceleration will show you how, let's say, to deploy Ignite in between your Node.js applications in your MySQL database. MySQL is taken just as an example. Instead of MySQL, you can use Oracle, Postgres, or anything else. We just decided to choose it as an example. So see how you can do this and try to repeat these steps on your side. Also, any questions, suggestions, concerns, feel free to reach out to Ignite community. And always you can go to GridGain and ask any questions to GridGain, or even you can go and download GridGain Community Edition, right? Which is a hardened version of Apache Ignite for production deployments. It goes with improvements and performance additions which are not available in Ignite, at least yet. So feel free to use it as well. And finally, final piece here is those of you who are using Ignite would like to stay with open source version, you can always rely on GridGain experts, which are still one of the biggest contributors to Apache Ignite. We know how Apache Ignite is designed, and we know how Ignite works internally. So if you want to talk to professionals, right, go ahead and you can leverage from our support for Apache Ignite deployments. Let's keep this in mind. That's it. So any questions? Feel free to ask.
Great. If you have more questions, you can submit them in the question dialog box, which should be below where you see your name. I think it is the sixth tab in the GoToWebinar panel. But what I'm going to do here is reorder some of these questions a little bit just to optimize, because I think one can follow the other. So the first question to bring up is, can I optimize how the Node.js connects to GridGain as a thin client? In particular, maybe co-locate the client, since it's a thin client, co-locate the client with a node or with a node in the cluster. How does that work?
So it doesn't. So here is there is no any embedded node, embedded deployment mode available for Node.js applications. And generally speaking, personally, I usually discourage from doing this unless you have microseconds SLAs requirements, microseconds, because the best recommended way to deploy Ignite, or I would say even any other distributed system, as a separate entity. So you dedicate a subset of machines for your cluster deployment, and they're sitting there. They have their own maintenance and deployment and release life cycles. I mean, whenever you need to upgrade your cluster, you will do this separately from the maintenance and release procedures of your applications. So the goal is to decouple your application, Node.js applications development life cycles from the maintenance of your cluster. Because I think that we would agree that if I'm updating my applications, trying to redeploy my Node.js code, I don't want to restart or affect MySQL deployments. We don't want to do the same for Ignite cluster. So here is, but what we did, so overall, it means that Node.js by nature, Node.js Thin Client, it will be working with the cluster through socket connection, network connection, right? Which means that that connectivity will already go through the network. And it's already optimized, right? The protocol is optimized. So here is you don't need to do anything else. Just develop your Node.js application and use that connectivity option to gain most of the benefits from the distributed system. Ensure that you understand affinity collocation concept. That's the way how the data will be stored in the cluster. For instance, you want to store related data on the same machines, like all of the countries from the all of the cities from the United States have to be stored on the same machine. It's easy to do with data modeling aspects of Ignite. And after that, whenever you're running, let's say, SQL queries with joins, those joins will complete fast enough, really fast. The same for the computations, right? Right now, as I said, the computation capabilities are not available for Node.js. But going forward, if they become available, then yes, you will be able to execute some code which is already deployed on their cluster side, and you will be able to trigger that code from the Node.js applications.
Okay, so I guess,
sure.
And this is sort of a follow-up on the same question. You could, I guess, then have two Docker Kubernetes deployments, whether they're actually deploying containers to the same physical machine or not, it wouldn't really matter. The life cycles could be decoupled. How does this all work with Docker and Kubernetes?
No any difference. You just like if to take Kubernetes as an example. There are several deployment options for Ignite. You can deploy Ignite nodes, your server nodes, your cluster nodes as Kubernetes pods, right? Containers. And you do the same with Docker. Customers do this. And then as long as your Node.js application is another container in, let's say, Kubernetes environment, then it will be able to connect to the cluster using this thin client. No any differences, no any complications. Or what other customers are doing, for instance, if to take OpenShift or OpenStack deployment, some of the companies have a policy of deploying databases or storages using OpenStack without any Kubernetes usage. And in that deployment, you still can have, let's say, Apache Ignite deployed in OpenStack without any Kubernetes, but Kubernetes can be used for your Node.js applications deployment. And those Node.js application containers, again, will be able to connect to the OpenStack cluster, Ignite cluster, using this thin client. It works without any issues.
Okay, and then calling SQL from within, let's say Node.js. Any recommendations for how to configure Ignite in the background for that if you're using Ignite and SQL with Node.js?
Yeah, so from the Node.js, Node.js is just a client, right? Which means that you as an architect or as a developer who is responsible for the data modeling just need to do some, preliminary, like first things to do, general, like design your data model in such a way that it considers affinity collocation, data collocation of your tables, of your caches. After that, that's something that is specific for distributed systems. Then, for sure, define secondary indexes. Which indexes you need, you can, for instance, find out this with the usage of Web Console or with any other tool. You can connect to the cluster and experiment with the performance, comparing execution plans. And also, finally, check our SQL performance suggestions documentation, which is available for Apache Ignite community. There we accumulated some of their low-level optimizations if they are needed. But usually, you're getting everything starts working out of the box in the performant way if you did two things: affinity collocation of the data and secondary indexes creation. The rest is just low-level optimizations.
Okay, so you basically look at the query within your Node.js and and define the affinity key based on the joins you're doing.
Yeah, you can, for instance, as I said, you can define your model, you define your tables or caches from Node.js applications. All that can be done, by someone else. By that like it depends on the company's on the company size, right? It can be the case that someone else is responsible for the cluster deployment, and when the cluster will be deployed, most of the tables with the affinity collocation and other indexes will be created in advance. And your Node.js applications will be just connecting to this cluster in production, and that's it.
Okay. Final question. We just got another question in. Which Ignite configuration, or how would we, what version of Ignite or configuration would we use in order to insert many records into an Ignite table in parallel via ETL? I think this is more of an ETL kind of question of doing batch or parallel versus just one record at a time.
So here is, I would suggest to, we have like all of those key value put all APIs which are available for Node.js client. They are not designed for real-time streaming because of the implementation details. We have some of their streaming APIs available at the cluster level. For instance, we have Ignite Data Streamer. Presently, it's not available for the thin clients like Node.js. That's why I would suggest you, until that gap is closed, I would suggest you considering tools like Kafka. For instance, if you're using Kafka already, or let's say Flink, Storm, or like anything else, those tools are integrated with Ignite. So you can put your endless streams of data in, let's say, in Kafka, and Kafka then will push all of the changes to Ignite through our streaming framework, through our streaming APIs. That's what I would suggest right now.
Okay, so for more bulk or streaming ETL, Kafka makes a better intermediary.
Yeah, because it's already like Node.js, our Node.js Thin Client is not integrated with our streaming APIs yet, but at least if you use Kafka from Node.js, and Kafka internally will be connecting to the same Ignite cluster, and both Kafka and Ignite already know how to work together through their most streaming APIs. That would be my
perfect. And I just got a real-time response saying that answered the question. So perfect. With that, Dennis, I think we've gone through all the questions. So appreciate all the time, folks. We will be sending out this recording in a couple days. In the meantime, if you have any questions, feel free to reach out to us anytime. There's always a contact us button on GridGain. We're always happy to help